Welcome back to Math with Miss Swartz. As we talked about yesterday, we're going to be working with dilations today. Dilations use similar figures in a transformation within a coordinate plane. So it's actually a pretty easy concept, but I want you to open to page 45 in your journal, and I want you to kind of just try this out. This is on page 45. So it says work with a partner. Just if you're working with a partner, that's great. If not, you can work on your own, but write the coordinates of the vertices of the blue triangle, and then write the coordinates of the vertices of the red triangle. So I want you to go ahead and do that, and then I want you to go ahead and answer A and B. See if you can figure out how the two sets of coordinates are related and how the two sets of triangles may be related. And see if you can explain your reasoning. Okay, so once you do that, hopefully you see really how these two sets of coordinates are related. That's the big piece, and we'll work from there. So once you've done that, hopefully you kind of put some pieces together, but I want you to write this down, all of this here. Okay, you don't need to draw the picture, but to dilate a figure with respect to the origin, which is how we're going to always do it, we're going to multiply the coordinates of each vertex by the scale factor of k. Okay, so what you probably saw in your activity here is that from the blue triangle to the red triangle, they were being multiplied by 3, the points. Each point was multiplied by 3. So that tells you something, okay? Each of those points were dilated by a scale factor of 3. So this tells you when k is greater than 1, the dilation is an enlargement. So in the case that you just looked at, it was enlarged. The blue triangle was made bigger by the scale factor. When k is greater than 0 but less than 1, so for an example, like 1/2, 3/4, okay, the dilation is a reduction, so it's going to make the piece smaller. But either way, all we're doing with both pieces is multiplying our scale factor by both x and y. So just like the last few transformations we've looked at, we're going to decide if a figure is a dilation, if two figures are have had a dilation happen, and then we're going to actually perform a dilation using a scale factor. Now, when we're working with dilations, these figures are not congruent, like we've been talking about. They are similar. They are proportional on their side lengths. Alright, so let's check out and see if we can figure out if each are a dilation. So if we look at A, we have the blue figure and then the red figure here. Well, it looks like they would be similar. We can't know for 100%, but it looks like they are. Their side lengths look proportional. The red figure is a little bit bigger than the blue, so I would go ahead and say yes. With B, these look about the same size. It looks like they just moved down, so no. Pretty simple. You do not have to draw these, but go ahead and draw these two. Okay, so number 1 here, this actually looked like it flipped over this point. This line here. So this would be a no. They look like they're the same size. But for number 2, go ahead and decide whether that is a dilation or not. Alright, so moving on, we're going to try to graph some on our own here. So it says, draw the triangle with the given vertices, multiply each coordinate of the vertices by 3. So our scale factor is 3 here. Alright, so our original point is at 0, 3, 3, 3, and 3, negative 1. Okay, so that's our original triangle. Now we're going to multiply each point by 3 because that's our scale factor. So 0 times 3 is still 0. 3 times 3 is 9. 3 times 3 is 9. 3 times 3 is 9. 3 times 3 is 9, and 3 times negative 1 is negative 3. So now we're going to graph our new points here. So we have 0, 9, 9, 9, and 9, negative 3. So the last question it says is, how are these two triangles related? Well, remember, obviously they're not congruent triangles. They're not the same shape and same size. But since we stay consistent with our scale factor here, each piece was multiplied by the same number, we're going to have proportional sides. We're going to have a proportion of 1 to 3. So here's 3, here's 9. If we simplify that, it would be 1/3. So they are similar triangles. Okay, so make sure you have this one drawn on a graph piece of paper with the new coordinates written. Okay, let's try this one together. It says, draw the image of a triangle ABC after a dilation with a scale factor of 3. So again, we're using 3. So our scale factor is 3. So we have 1, 3. That's A. 2, 3. That's B. And 2, 1. A little small triangle there. So we're going to multiply each piece by 3. So A prime is going to be 3, 9. B prime is going to be 6, 9. C prime is going to be 6, 3. All I did was multiply 1 times 3, 3 times 3, 2 times 3, 3 times 3, 2 times 3, and 1 times 3. So I'll graph these new points. We got 3, 9, I'm fixing my graph here. I realized I graphed this wrong. 1, 3 is here. So it should look like this. Whoops. Alright, so now we can go ahead and graph this. So we got A, and then we got 6, 9, and then we have 6, 3. So B prime. Oh. There we go. So this is an enlargement when it says identify the type of dilation, because it got bigger. Remember, we can have either an enlargement or a reduction. Alright, so for the first time we're going to try a reduction because we have a scale factor of 0.5. So we're going to start by drawing the image. We got negative 4, negative 6. Is that W? We have negative 4, negative 8. That's X. 4, 8. Y, and 4, negative 6 is Z. So we're going to multiply by 1/2 or 0.5. So we're just taking a half of everything. So W prime, okay, is going to be, well, half of 4 is 2. Half of 6 is 3. Okay, again, half of 4 is 2. Half of 8 is 4. Half of 4 is 2. Half of 8 is 4. Half of 4 is 2, and half of 6 is 3. So our new points are at -2, -3. I should do it in a different color here. -2, 4. Apparently I'm really struggling to graph or read these points because I graphed this graph wrong again. Oops. Alright, gotta erase all of this. So those are at -6, but -4, 8, and 4, 8 are way up here. So that would be X and Y. Oof. Some days, you know. Alright, so once I do that correctly, I've got W prime here, and then we got -2, 4, X prime, 2, 4, Y prime, and then 2, -3, Z prime. So as you can see, the type of dilation is a reduction. Oops. Goodness gracious. At these points. Okay. Alright, so this is getting long. I'm going to have you try this one on your own. You're going to multiply by a scale factor of 3 here. Make sure you list out the coordinates of the image. Have a great day.